So here's another cool Raspberry Pi project. This time it's an analog to digital converter, and what I'm doing is I'm taking a thermistor right here and I'm reading the voltage across it and then converting it from an analog signal to a digital signal with this MCP 3002 analog to digital converter chip. The Raspberry Pi can't read analog data, it can only read digital, so if you want to do anything with analog sensors, you have to have a converter circuit like this. And what I did was I've got it set up with sockets that I can plug into. So I've got a thermistor here right now, but I got a bunch of other thermistors too. So I mostly just wanted to see if I could make this work, and it does work. What I'm doing over here is I'm taking the voltage data and streaming it to initialstate.com. And those two spikes you see that go down, I got those when I heated the thermistor with a hairdryer. So this thermistor has a negative coefficient, that is, as the temperature goes up, the voltage goes down. So let me show you. So what I'm doing is I'm heating the thermistor with a hairdryer. And what you can see over here, this is streaming the voltage across the thermistor. So you can see I was in the mid 160s at room temperature, and then I hit it with a hairdryer and it came down to mid 80s, and now it's going back up. Okay, and if you come over here to the display at initialstate.com, you can see over there on the right hand side it's recording the data. So what I'm going to use this for maybe is I want to set up a temperature control on my grill, and I want to use the temperature of the grill to drive a servo motor. So I bought a servo motor that can vary its output angle between 0 and 180 degrees, and I got it to work. But there's a lot of jitter in it too, and apparently that's a feature of any Linux-based microprocessor. Apparently Linux isn't very good for machine control. So there's a breakout board that I think I need to get that's designed for driving servo motors. So that'll be another project. Okay, but you see over here on the right, you know, it spiked down and now it's going back up. Okay, so there you go, analog to digital converter circuit.